Video, we're going to look at example 4 from section 4.3, where we multiply a rational expression by a polynomial. So what's different for example 4 from example 2 or 3 that we covered, I believe example 3, is that the second term here is a polynomial. It's not in, let's say, fraction form. So what we're going to do is we're going to write this as x plus 2 over x to the 4th minus 16 times, because we're looking at products, x cubed plus 4x squared minus 12x. And what we're going to do is we're going to make this look like a fraction by placing it over 1. So quite simple, right? Divided by 1 doesn't change the value of anything, so we can rewrite it as divided by 1. And then everything else is the same. So if we go back to example 3 here in part B, what we did was we looked to factor, we talked about domains, and then we combined our fractions together through multiplication, and then reduced or canceled anything out that we could. So we're going to do the same thing here. Now we want to factor. The x plus 2 can't be factored, so we're going to leave that alone. The x to the 4th minus 16, that's the difference of two squares. So that's going to become x squared plus 4 times x squared minus 4. Okay, good with that. The second one, and then you'll actually see that there's actually more to do here. This is another difference of two squares, so we'll be able to factor that again, but we'll get to that in a second. The x cubed, so now we're looking at this term. The first thing I notice is that they all have an x in common, so I'm going to take that out before I look at a factor sum chart. So I'm going to say x times x squared plus 4x minus 12, right? Because we factor out that x. And then again, we're going to keep that 1 there. Continuing on from here, we want to go through it step by step, and then I'm going to go back to domain. I'll talk about that at the end after we finish the problem. So I'm going to look to factor this again if I can. So x plus 2, x squared plus 4 is the sum of two squares, so we're going to leave it alone. But the x squared minus 4 is the difference of two squares. So that's going to be factored again into x plus 2 times x minus 2. Let's throw some parentheses around that. And then let's multiply by x. My numerator, the x squared plus 4x minus 12. I want to see if I can find factors of negative 12 that add up to 4, which I can. Those are going to be x plus 6 times x minus 2. Right, because 6 times negative 2 is negative 12, and 6 plus negative 2 is a positive 4. And once again, we'll keep that over 1. Here would probably be the best time. So factoring is done. Here's the best time to look at the domain. And our domain, remember, is for our values in the denominator. So for the domain, I'm going to write it all the way over here so we have some space. We're looking at all real numbers except, remember, the numbers that create an undefined expression or an undefined term. So those undefined terms, this domain here, is going to come from over here. And we want to ask ourselves, how does this, or this piece ever become 0? Well, x squared plus 4, x squared plus 4 is always going to be positive. No matter what I square, I'm going to get a positive number. And by adding 4, that number is going to get larger. So making a positive larger will stay positive. So this piece here is okay. Right? The x squared plus 4, there's no limits to what we can have there. But the x plus 2 and the x minus 2, well, I know that I can't have a negative 2 there, and I can't have a positive 2. Because if I do negative 2 plus 2, that's going to be 0, and 2 minus 2 is equal to 0, and we cannot have those. So my domain is set up. Domain is all real numbers except negative 2 and 2. And we keep that in mind, and we look at that again at the end after we've reduced everything. From here, you can start canceling out. I'm going to write everything together. Right, it's not going to be in the nicest form or the most organized, but remember, top times top, numerator times numerator, and denominator times denominator. So I'm just going to write all these pieces, all these expressions together, and now I can start looking to cancel things out. So I see here I have an x plus 2 up top and on bottom. I see an x minus 2 on both the top and the bottom. Can't cancel out the x. I can't cancel out the x plus 6 or the x squared plus 4. So this expression is going to become x times x plus 6. We can leave that as the factored version, so we'll leave that alone. And in the denominator, it would be x squared plus 4. Now keep in mind, this denominator in this specific form here, there's no limits. All right, everything is okay in the denominator. It's impossible to make that 0. However, because we did have to look at the denominators on the previous steps, we do need to remind ourselves that x cannot be equal to 2 or negative 2. And that comes from our domain. Let's bring this down here. We want to keep that in mind. So this would be our product, and this would be our domain. Either way, you can write it out as domain all real numbers except negative 2 or 2, or you can say that the domain is x cannot be 2 or negative 2. It's up to you. All right, and that's it. This is very similar to example 3. You just have to factor, reduce, cancel things out, combine your numerators, combine your denominators, and just watch out for the domains.